All right, lesson 64. Again, we always want to start with our vocabulary, our terms, our words, anything new that we're learning. Okay, we have the word domain there. And on the top of page 261, we'll see the definition for that. Gavin, would you read that for us?
Page at the top.
261.
Read that. The set of permissible replacement values for the variables in a particular equation or inequality is called the domain for that equation or inequality.
Every equation and every inequality has a domain, okay? It's the numbers that are permissible to be replacement values for the variables. For example, and you say, what do you mean the numbers that are permissible? We haven't talked about this a lot, okay? But you can never have 0 as a denominator, right? And we've all done this in your iPhone. Try dividing by 0 on your iPhone. Ethan, have you tried this?
Sorry.
Yeah, right? You can't do it. So, if I had an equation that looked like this, can 0 ever be x? No. So that would mean my domain could not include 0. If I had an equation like this, your domain can be any number in the entire world. So you would say all real numbers. Okay, that's your domain. Your domain equals all reals. So that's kind of what we mean by what we're saying, domain. We have also integers we've talked about, positive integers, negative integers, and they're going to give you those parameters for these problems. So, what are we talking about? Let's go straight to an example. It says graph. We're going to graph these expressions or these inequalities. On a number line, we have x is not equal to or less than -2, and the domain d equals positive integers. So those are the only numbers I'm going to use in on my graph. So graph my number line here. 0, 1, 2, 3, 4. -5, 1, 2, 3, 4, 5. All right, x is not less than or equal to -2. So how would I then translate that into how would I write that? What is x? If it's not, Diana, how would I translate that? Anyone? This goes back a couple lessons. If x is not equal to -2 and not less than, then it means x is what? It's not less than, it's greater than. It's not equal to, it's not equal to -2. So x is greater than -2. Normally when we graph that, that would mean open circle on the -2 and this way. But here's my domain. I can't use every single number on this number line. What am I excluding?
Negatives.
I'm excluding negatives. I'm excluding fractions and decimals because it says only positive integers. So, and I'm excluding obviously -2. So you can, -2 is not included, but I will start at -1 and I'll just include that, and 0, and 1, and 2, all the way up here. But it's only positive numbers. Oh, it's only positive numbers. You guys see what I did wrong?
Put a negative.
I did. I graphed the negative. So it's got to be only positive integers. 0 an integer. Yes, it is. Okay, I think we're out of time. Are we? We have another minute?
Two.
We have two. Oh, I love it, Gavin. Your enthusiasm to keep going makes me so happy. All right. So what if we had a problem like C? C says x minus 5. C. X minus 5 is not less than 0, and your domain now is just integers. So we're going to first, let's draw our number line here. Okay, we'll rewrite this. If x minus 5 is not less than 0, then what is it? X minus 5 is what?
More than 0.
Greater than or equal to 0. And from that, does this make sense? What do I want to do here? Isolate the variable. So how am I going to isolate the variable?
Put the 5 on the other side.
Right. Opposite operation. I'm going to add that opposite. Forget it. Opposite operation. I'm going to move that 5 over, or just say add 5, and I get x is greater than or equal to 5. And we can do that because of the additive property of equality and inequality, which is in here again for reading for later. And then you can simply graph that, but remember my domain is integers, so I can't do the whole number line in my pretty little arrow that I usually do. I take all the numbers that are either greater than or equal to 5, so I can include the 5, and then, all the numbers higher than it.